I will start with what is BIM, because I was taught when we teach we have to establish that everybody has a certain level of understanding. So what is BIM? It's this thing between tools, processes, and behaviors. So to go a little bit deeper into that, behavior and tools will create all your experts. So we train our students to become experts, so they change their behavior, they change their the idea of how to use certain tools. And then we focus on tools and processes. So between tools and processes, you're going to have standards. So going to what Joe was saying, some of the things that they were struggling is putting these standards into place. So how the tool will change the process now. And then behavior on process, that goes to if you want to make sure that people are following the process, and the you create the standards, and then to enforce the standards, you create contracts. So having said that, that's big. So now, what am I going to talk about today? I'm not going to talk about exactly this aspect of BIM. Now, before I start, I want to just briefly touch into what do we do. We got a $2.4 million research grant from ANSWER to actually explore the tools that I was talking about, processes, not behaviors. We have had almost 32 research projects with different partners. And what is the most important, and I'm more proud, is we had 20,000 hours of student work. So our students are the ones that will actually do the projects. We guide them through the process, teach them the tools, but they have to, working with us, they come up with the solutions. So now we go back to our case studies. Like, the problem with BIM is data. There is a lot of data. What do you do with it? So constructors need data for different purposes. Facility manager owners need that for different purposes. So how do you make sure that the data that you need is in your model? So these are things that we try to figure out. So for buildings, working with the data, coming up with all these Excel spreadsheets that facility managers use and try to operate the buildings. So we have 3 projects, and in these 3 projects I focused on how the data was created, or how the data went from one software to the other, or how you can use the software to manipulate the data to create some automation in the process. So, and all of this was done with the purpose of how can it help someone in the facilities management or an owner with their assets. So we'll start with the Victoria Park Chesterley complex in house. So we partner here with Toronto Community Housing. And one of the challenges they have around 2,200 buildings around Toronto, and they have no data. So every time they need to do any work, they have to start to do the survey, to start building the CAD, and then they have to compare that with the original survey from the 70s or the 60s that was scaled a couple of times in PDF. So the idea was, okay, how can we use the technology to actually build this information so it can last for a longer time? So we had a big research team for this because, as you see from the map on the site, it was 2.5 kilometers of square kilometers of an area. So the main focus was not the building's interior, but everything that had to do with outside. So landscaping, roads, curbs, facades, buildings, anything that was on this 2.5 square kilometers, we had to record and create these models for facilities purposes. So the first step we had to do is, okay, let's identify what are the tools that we're going to use for this. So if we go back to our first slide, tools, processes, and behavior. So what are the tools? So for the tools, we decided to use laser scanning. But at the moment that we were using the laser scanning, we also wanted to georeference the laser scan. So all the data that we're going to have on the scan was georeferenced. So we have the X, Y, Z elevations. So to do that, we use this scan sphere. So basically it has I'll become a little bit technical now. It has these prisms that you can actually locate where exactly that point is set up. So first we had to actually create the points on site. So we created 8 points, and to make sure that we had control over this large area, we created 4 control points on one corner of this area and 4 control points on the other. So when we started to scan, we started in one of the areas, and we registered that with the geolocates, and then we ended up on the other side and we checked, okay, how accurate the registration was done within the software. Now, when we finished all the logistics of how we're going to do the scanning, we spent almost a week or 2 weeks on site, so the students were very eager. We used like four scanners, so we had 2 teams going one this way. So there was a lot of learning we had to go through there, because now we had 2 sets of data that later on we had to put together. So all scanners were labeled with names. The cards that we used were labeled. So everything that we did was labeled to exactly know what the process was. So if we had any issues later on, we know exactly which scanner was it, at which location, so we could go and rescan that area or see how that could be fixed. Now the funny part is that after we did all of this successfully, then we had to start and use Revit to build the model for the site. Initially, the partner, Toronto Community Housing, said, oh, we don't want a Revit model, we just use AutoCAD. And I said, okay, we'll try it with AutoCAD. So the students started, and after a week they came to me, either we do it in Revit or we quit, we don't want to do this. And I said, well, why? Well, what happened? And I said, well, if I do it in AutoCAD, then I have to go, if I miss something, then I have to go and change all my elevations, I have to change all of this. And I said, okay, let's use Revit, and then let's explain it to the partner, this is the way we're going to do it. And they said, and at the end, we still can export the AutoCAD, so the people still can have the data they want. So after we did that, we kind of checked the process of from point cloud going directly to AutoCAD. That lasted a week, and then 2 or 3 months we actually focused on Revit, and then from Revit we exported also Civil 3D, but I'll explain that a little bit later. So after we have established the process, then we said, okay, now how are we going to manage this data? Because the scanning alone was 1 terabyte. So 1 terabyte of scanning is a lot of data. So this is that point on the site where we actually put the georeferences. And we have the elevations like northing, easting, and then this was our first scan. So we scanned with this, and then anytime we would register, we had this as our initial scan. So this was very important because we wanted to convert the point cloud into a surveyed point cloud. Then there was a lot of work to clean the point clouds because I don't think they were interested in how many leaves there are on the trees. So we just figure out that up to 1 meter at the trunk of the tree, just to know how big the tree is. That was enough information for this exercise. So we had one student, very patient, went and actually cleaned 1 terabyte of data and learned a lot of how to manipulate these things faster. So we also created a process of how you should actually do this. After this, we started with, as I said, with AutoCAD. So it was very limited and also very grainy in the software. So it was not meant for that particular process. Then what we did is when we brought the point cloud into Revit, we already had the point cloud georeferenced. So we started in Revit with the actual XYZ. All of our model is georeferenced. All of our plans are georeferenced based on those 4 points. So we use the point cloud as our survey to bring it inside the model. So we didn't have to struggle after, okay, how do I change the true north? How do I change the origin point? Like the 3 different coordinate systems in Revit, which is, you don't want to mess up. And after that, we were able to actually produce the Revit model. And also, we had a lot of information embedded into it. So here is how the workflow actually went. So point cloud, Revit, and then at the end, the students always like renderings that they say that it looks nice. They get ownership in the rendering when they do the renderings. Now, going back to one of the important points, so we had the red point, the Revit model is elevation 188.42 meters. And then we check the survey from 1979, the elevation is 188.47. So we only have 5 centimeters of discrepancy. So in 20 years, I don't know what the reason is. Hopefully that will not be one of the questions. But 5 centimeters, I think, is a pretty good. And we checked also other points. And the biggest discrepancy, I think it was 15 centimeters. But that also has to do with how some of the point clouds were registered and whatnot. Because in some point clouds, we had around 26 millimeters difference. So that actually might be one of the issues. So after we did this, then we had the meeting. Everybody was happy. Hey, look at this. We have a drawing. But what can we do with this drawing? With this 3D model. And I said this. If you want to change the doors, you have 361 doors. This is the elevation of the door. These are the dimensions of the doors. Some of the challenges they have is, for example, if they have to change the windows, and they have 1062, a trade will go and measure just a typical window, and then just, so sometimes they have like 5-inch gap on the window, or 6-inch. So all of those issues that they have, they started to say, okay, now we know how to use this. And when we had to deliver all the project, they said, oh, but we want something else. I said, sure. Can we have one of your students so they can operate this? I said, yeah, that's fine. So it took some time to actually put all of this together, but what was the important thing was that we actually recorded all these steps. Record all these steps because we're in academia, so I hope I can teach this to my students in class. So all good things that you have to do and all the things that you might have an issue. So how does the tool helps you when you're actually building something? Because at the end, if you don't have the process, the tool will not, you're just going to produce data. But how you use that data is the key, I think. And I think in this particular project, what we try to do is, okay, there is a site, we have no drawings, we have no information. We acquire the data, we use the laser scanning, and then we build the model. So for the facilities management purpose. So our model had no foundations, too. But we had all the roads, curbs, retaining walls, green space, everything else was modeled. And that's the first project. Now, on the second one, we wanted to check off the box. You get softwares. Now, all of them claim to do miracles, so we want to see how the miracle works. So, I think I should go on the next slide. We compared Archibus, Maximo, FM system, OpenMaint, BIM 360 Ops, Ecodomus, BIM server, and Forge. So we started with this table. And in this table, what we did is, okay, let's see first of all which softwares can we use, what is the cost. So all the important things are reporting and analytics. Okay, so what type of reporting and analytics this software will do? Automation, controls, sensors. Do they have any of these capabilities or not? Then we went to BIM Revit connection. Okay, so they say that they have a BIM Revit connection. Okay, so we're going to explore that. Then we go 3D browser, viewer. Do they have it, yes or no? Okay, now, when we started, we were very optimistic, but some of the software providers didn't want to give us the software for free, so we had to buy the software for 1 month. So we said, no, we don't want it. Well, if it's $50,000, I don't think anybody will pay $50,000 just to test something for a month. But anyways, so and at the end, we actually ended up with these three software: OpenMaint, Archibus, and BIM 360 Ops. So these were the ones that we could actually test and check what they can do. Now, BIM Server and Forge, we could have gotten them for free, but because it needed a lot of coding and setup, we said in a month it's not feasible. So after that we said, okay, we went to COBie standards and we said, okay, let's analyze how we can structure the information in Revit using COBie, and then we're gonna test that particular information to go from Revit to the other software and see what off the box will automatically happen without us doing any other efforts. So BIM 3D model, we identify the space and the equipment that we want to go to the facilities management software, and then assign all the COBie requirements, and then from that we go and check the data. So in BIM we checked element properties, rooms, and all the Revit parameters. So based on how we connected that with COBie. Then on COBie we checked workflow, when we wanted this information to be embedded, what information was included, and what parameters we were measuring. So we needed to know all of that information in our COBie spreadsheet. And then at the end, we were checking, okay, which data from this actually exported from Revit to the other three software. Because this would give us the idea that, okay, if we need to put this information in a facilities management software later on, we would know that, okay, we have to do extra work or we don't have to do extra work. So I'll start with OpenMaint. We did not tested it because the free version you could not do anything with it. They wanted money after. So, but Archibus, there were some data transfer, but it needed a lot of setup. So you had to initially do setup. Like if you get a Revit model and you just say, okay, export this data, not much data will automatically go from Revit to Archibus. Building Ops had a very good data transfer, but Building Ops has its own limitation. Like it doesn't have an open API, so you cannot really do other things if you want to. But also one of the positive was that the information, if you put it on Building Ops, it could actually update your Revit model. In Archibus, that doesn't happen. It's just one way. I don't know if they have changes, so this was last year. So that was in terms of understanding how you can transfer data from Revit or BIM authoring, which we, I think I'm getting dry. So how we could take the data that we need to use from Revit to the facilities management software. And now I'm going to go to the last project, which actually focuses on how you can use Dynamo now in an existing model for facilities management purposes. So, in our program, we have a BIM program at the college, so the students have to come up with a project, a capstone project. So I asked them to learn something that they have passion about. So whatever you want to learn in your capstone, come up with an idea that you like to explore. So I don't have rules in terms of, oh, you have to find out this. No. Whatever you want to explore, find a problem and solve it. So they said, oh, we want to explore Dynamo for facilities management. I said, great. So how are you going to start? They said, oh, we want to build a floor plan, and after we build the floor plan, they build the mechanical model, and they said that, okay, we want to see how we can use Dynamo to understand the information embedded on air terminals. So if we want to change any filters on air terminals, or if we want to do any updates, we want to visualize that information. So what exactly they were looking is to check, so Dynamo could calculate how many days you need for before service or a change needs to be done to the terminal. So how can you do that service? Then they had to import, this was all done in Excel. So we were thinking that, okay, there is an existing facility, and all this data usually is stored in Excel. So how can we use Dynamo to actually import this into a model and start using the model for facility management purposes? So this is the Excel spreadsheet. So they built the model, and then they had this, they built this Excel spreadsheet. So they said, okay, we want, they put the levels, so rooms, model, manufacturer, a mark, and a service date. So each of those air terminals had a service date with a particular amount of days remaining. So if it was within 30 days that this air terminal had to be serviced, they highlight it in red, so it will show in the model. If it was between 31 to 90 days, then it will highlight in orange, even though it's yellow. And then green means that you have around 365 days to do any services, and over 365, it's not colored. So this is the script. So they came up with a script, and all of this is off the Dynamo tool. Like they didn't have to do any Python coding except a little bit in here when you populate the parameter that they have to assign the number of the days with the color to match. That was the only time that they had to. And they did all of this work in 3 months as part of their class. And I asked them to be here today, but they're too shy. But, so after they completed this, oh, that was my pin. That's where you have to code. So after that, we were able to see, okay, this is the Excel spreadsheet, the original one. This is where in the properties it will be located. And then it shows that Office 2007, the air terminal, has only 471 days left. But that's minus, so somebody forgot to change it. So you can do, you can use this for any other thing that you need to check. The only thing that you will have to change is, instead of an air terminal, you can check, okay, how many chairs do I have? How many desks? Where are they in the building? So that particular code now, by changing a few of the properties, can be applied to a lot of the elements in the facility. I have 3. So this was one of the scripts. So one of the scripts was, okay, you have an existing facility, you have an Excel spreadsheet, you build a model, how do you link the information from that Excel spreadsheet to the model and how you visualize it. And then the other one, we said, okay, what happens if you already have a Revit model now? So they did the opposite. They exported the Excel from the Revit, they went in Dynamo, put the script again, and they came up with the same results. But if you have the model, it was a little bit easier because you didn't have to script anything. Because the way you are marking things in the model is much more easier.